Hi, I'm going to talk about spylon-kernel. This is a project that I sort of hacked up over the holidays, mostly as a reaction to another project I work on. So, my name is Marius. I'm a full-stack data scientist. I like that term. I think we should use it more. Because we get full-stack engineers, but full-stack data scientists is like you can dig in the weeds and like dig into the core of Spark, and you can build a model as well. So, I think that term deserves some using, some more. I don't know, but it's like I'm one of the first people that I think have used it. So spylon-kernel is yet another Jupyter kernel for Scala and Spark. So, I mean, why did I do this, right? We already have Tori. We have Jupyter Scala, which is pretty good. And we have Livy, which is slightly different, but also quite good. So, do we really need one more of these things? And so the answer is yes, we do. So all of those things are written in either Java or Scala, and then they re-implement the Jupyter protocol. So what that means is every time that Jupyter changes, you have to go dig through a whole bunch of Scala code and go rewrite that. That's kind of awful, and a lot of that code is, you have to go write. Particularly if you're used to the Python space and you're working with Jupyter things, you're not necessarily a Scala expert. You know Python quite well, but you don't know how Echo works, and now you have to figure all that stuff out, and that's a lot of work. So instead of that, let's do spylon-kernel. So it's written in pure Python. There's a little asterisk there, but it's mostly pure Python. And it uses a project called metakernel, which is an excellent project that's out there for assisting people to write their own Jupyter kernels. There's a whole bunch of things that are written using metakernel, and it's very simple to get a simple one that basically uses pxspect style things working. And if you want to do more fancy things, you can obviously do that too. There are metakernel packages for things like Hi, which is a Python Lisp, and a whole bunch of other stuff. And the other one is that for Spark purposes, this one will lazily start your Scala interpreter, which is a useful thing because there are certain properties that can only be set at initialization time. So particularly for when you start up your embedded JVM that runs this, you have to tell it how much memory it's allowed to use. So typically with Tori, for example, that's fixed and it's written into your kernel spec itself. So you cannot change that once it's started up. So this gives you a lot more flexibility in that sense. So you can get it. It's easy. It's pip installable, and then you have to install the kernel. If you haven't actually installed kernels before, that's how you do it. In most other things. This will obviously assume you have the notebook and all of those things, and if you don't, you should get that. And it's on GitHub, but Maxpoint spylon-kernel. So let's do a little demo on like what this crazy thing actually is. Cool. Zoom? I'm going to zoom. Just give me a little second. Okay. Are we good?
Very.
Okay. Kernel. Let's clear all of our output because we don't need output. So whilst I said that this is a Scala kernel and it technically can be used with other Scala backends, right now Spark is the only actual supported way to do it. If you can start up a JVM that has all the necessary other compiler machinery itself, then that'll work too. Right now, this is kind of geared around Apache Spark. So you can start up a Spark context. We're just starting one locally. And once that guy's going, so this will take a little bit of time. And now we can write some Scala. So the trick here is that there's a bunch of magic going on behind the scenes here. So init Spark basically calls spylon, which is a library that I talked about at PyData Carolinas. So it uses spylon to actually start up its various pieces. And then inside a Python process space, you start PySpark. But because you start PySpark, you have a working JVM on the other side. And there's basically only one magic environment variable that you have to set, and then you can use that JVM to go and start up a Scala interpreter, which we've done. So what we now have is I can have a Spark virt, I can call these things, and I can build Scala sequences and things like that, as well as, create myself some data sets. So this will create us a data set, and you have, full tab completion and all of the standard things that you expect from a kernel. But this is all done and implemented basically via Py4j, talking a lot to the Scala backend. So there is some relatively minor performance, cost in that communication channel there, but typically you're not going to be sending lots of things around. You're basically going to tell Py4j, go build me a thing. And it'll run in the Java space, and then you're kind of okay. And you can define classes, and that all works. So I've made a class, and I can map my data set that I've created previously into that class. I can define functions. That stuff all works. What's quite interesting is that the Spark context that's underlying this stuff is shared between the Python side and the Java side, because we made it on the Python side first, and then we use that thing to go and start up our Scala REPL on the Java side of this thing. So I can go create a view for this data set that I've made, and then there's a Python magic where I can just run normal Python with, and I can make a data frame and collect some things out. So now I have a Python data frame. And just to not show you this, I can, right. So that's just standard Python, nothing special. Tab completion also works inside the Python cells, which is kind of nice. So you typically, so Tori will have, for example, Tori will have tab completion only in the Scala cells. So we'll have it on both sides of the equation, which is kind of nice. And also, because you're closer to Python, you can use matplotlib, which is kind of one of the big reasons why I made this. So using matplotlib is a little bit more torture than it usually is. We have there's a whole bunch of magic that IPyKernel does to get like the inline backend working correctly. But you can do some simple plots. This is just some plots. And we can do some things, and you get a plot. Also note that this is, I think this is using Matplotlib 2, which people should be using roundabout now. So the only difference here is that basically I had to go write this thing out to a file and then retrieve it again, and then wrap it in sort of IPython's image class. This is essentially the magic that you need to actually get the thing to show up. But once you do that, you can get like you can get something that's close enough to your Python side that you can still do useful plotting, and if you need to, drop into the big data side of things, you can write a lot of Scala. So that's that gives you a lot of more flexibility. And the nice thing about this is, all in all, this is something like 1,000 lines of Python for the entire library. So it's a lot easier for people to hack on, because there's not that many moving parts. You don't have to go learn Java or Scala. There are some pieces that will essentially, once the interpreter is invoked, it'll go and do some Scala pieces to set up like the proper Spark contexts and make sure that things are importable properly. But that's basically just eval calls once you have it going. So even doing that is not that complicated. So the other part that this library can also do for people that are sort of more adventurous and want to do even crazier things, because now it's kind of crazy writing a pure Python Scala kernel. But what you can do with this now is, the way that this is architected is spylon-kernel also provides you with a magic, just like the R magics and things like that you can do %%R. So you can install the spylon-kernel magic, and you will get a %% Scala that you can use inside a standard IPyKernel Python notebook. And that gives you the ability to basically drop into a Scala session when you need to, and work in Python for pretty much the rest of the time, which is typically the way that people would like to work in the data science space, in my opinion. It's like, I've seen a lot of people, it's like teaching data scientists Scala is kind of painful. So, just let them have their Python. It's great. And if you need to go write some more fancy, some big, complicated, fancy Scala thing for performance reasons, drop into it right there, and that's it. You don't need to do anything more complicated than that. So this is sort of the ultimate idea that sort of I started back, almost a year ago when I started Spylon. And I think it's close to being, a really, really good suite of utilities now. It's all open, and we're now basically at the point where more users would be great. Just getting some people to kick the tires and show some cool stuff that you can do with it. So, okay, and I think my slides are basically that. Just moved it 5 pixels to the left. So this is, yeah. So I don't know what that slide is from. I suspect that's a slide from my lightning talk I gave at SciPy, so ignore that slide. Yeah. So, any questions?
So, what were you writing out that you said you had to do some I/O to write out and read back in something? What were you writing out and reading back in?
So, what I was writing out is I was writing out just a PNG file, just to a temporary location. So this was just reading and writing a ping just so that I can load. I can also write it to memory if I want to, but the main thing is you have to go and essentially go tell Matplotlib, please go make me a ping, and it'll go do that. So you won't get the automatic thing where if you've done %matplotlib in line and you've done a cell where you've done some plotting, it magically shows up a plot below it. That's not quite there yet. Those pieces are complicated, and IPyKernel is a little intense there.
Is it possible to access like data sets that you've defined in Scala in Python cells?
Yes, it is perfect. It is completely possible. So, there are 2 modes of interaction in which you can define things in Scala and Python. Using the kernel, you can basically create a view of a Spark dataset, and that will basically define it by name. And then on the Python side, I can access it again. If you're using the magic, then you can basically just run a hunk of Scala, and it will return to you a JVM view wrapper object.
Okay.
That's basically the same way that Py4j does. So you'll get back a reference in your Python space to your Scala data frame, and then you can wrap that into turning into a Python data frame, or Python Spark data frame. And you can do the same for any other thing you define. So it's not constrained to just Spark data frames. It's any Java thing, with probably the exception of like, a class definition, because those don't actually exist as real things you can interact with a lot. Cool.
Can you put the page up one more time of how to get to it? And
Sure.
I want to make sure I tweeted the right one.
Yeah.
GitHub.com, Maxpoint.
GitHub.com, Maxpoint.
Maybe on Meetup website or whatever it is, with these things so people can build it.
Yes. So the examples are up on.
No, what I'm saying, the Meetup,
Oh, right. Yes.
so.
Go ahead and ask him. We got a question over here.
Sure.
They're asking me,
I didn't want to ask this question because I don't know much about the Python and Scala. But the question that I had was I saw you interacting with the browser.
Yes.
You're actually writing the code in the browser. What is that?
So that is the Jupyter Notebook,
Okay.
and the Jupyter Notebook is awesome. It is. If you want to hear lots about the Jupyter Notebook, you should ask Pete back there. He's going to stand up now. Yeah. Pete does a bunch of work on Jupyter, but basically what the Jupyter Notebook allows you is it provides both the notebook and this communication protocol by which you can interact with this notebook, and it will send code to go and evaluate in what they call a kernel. Unfortunately, there's a bunch of things called kernels, but there's a Jupyter kernel, and a Jupyter kernel will be this thing that knows how to evaluate your hunk of code and send back rich output to this front end.
And the only language available which is Python?
There are there's around 60 different languages that are.
It gets its name from the three languages that started off Julia, Python, and R.
Yeah.
Jupyter.
Yeah. Yeah. So those three languages are very well supported. If you go into, more esoteric things, you end up in either hobby projects or some interesting things that some of which may be abandoned. This might be a hobby project. I'm just going to say. But there are a bunch of Scala kernels, so you can definitely find some things. If you're, some of the things may be a little not so great these days. I think there's a closure kernel because there's a reasonable closure community around here that may care. I'm not sure how well that one works, but it's around. There's also a bunch of crazy stuff like there's a C++ kernel, which actually works really well.
I'm wondering, since we're talking about Jupyter, what level of Python this was written to? Is this a 3?
This library will only work in 3.5 and up.
Okay, and so that's important. And did you try to install on Anacondas?
So there is a Conda Forge package that is coming. Travis is kind of backed up, so it should probably drop in the next couple of days.
Okay.
So Conda Forge packages for this will be available. It's just, I made the Conda Forge packages for this like 2 days ago.
Thank you for the work on Spylon.
Yeah.
wish you the best of luck in New York, and we're gonna miss you.
Cool. Thanks.